Hello everyone, good evening. My name is George Vahelazra and I'm glad to welcome you to this video. This is how you'll see how we'll work on the prepared data on this telecom customer churn prediction dataset, and follow me as I lead you through. The first thing I want you to know is that before you start any data science project or analysis, you need some libraries. These libraries help us to be able to manipulate, to pre-process, to visualize, and to work on the data so that we can have a viable end product. Chief among some of the libraries that we'll need are the pandas, which you can see here. The pandas help us to have is more like a data frame that or you can view it as a Python worksheet through which you can be able to visualize our data and be able to work on it. We have NumPy, which is used for numerical calculations. We have the sklearn. sklearn help us to split the data, to scale it, and also to prepare it for modeling. While from this particular library, the implement oversampling, we import the smooth, likewise the standard scaler for scaling, and the matplotlib and the seaborn are actually used for data visualization. So first of all, I'm going to import them. I'm going to press Control Enter and import them. If we don't encounter any error, it means there is no problem, we don't have any typographical error. The next thing I will do is to import or load my data set. Without data set, we can't work on which data are we going to work on. So we have to import our data set, and I have my CSV file, the customer churn data set. I will have to copy it so that I can be able to have access to it and to portray it here. You can see I've already copied it, and we are going to read it using the you see PD here, like I told you earlier on. The PD stands for pandas. It's a short form, global acceptable form of pandas. DF here stands for data frame. So I'm going to read it so that we can be able to access the contents of the data set. So once I press and Control Enter, if there is no issue, we will be able to have access to it. And how do you know that we have access to it? We can use DF. You can see this is our data set. We have almost 7,000. You can see 7,043 rows and 21 columns, which means from 0 to 7,042, which is shown here. We have so many columns, 21 columns: customer ID, gender, senior citizen, partner, dependents, and I think we also have at the end of it we have payment method, monthly charges, churn. All these are part of our CSV file, which we are going to look into it. And if we are going to look into it, we have to find out patterns. The patterns are what will help us to be able to know and gain insights from a data frame. If I don't want to see it all, I can choose to see just a part of it using df.head, and it will show me, I think, that 5 rows and 21 columns. This is the top, and as you can see, this is our data frame. So the next thing we'll do is to try to know a little more about the data set using that df.info. The df.info gives us the information about the data set, and like I said earlier, the range index ranges from 0 to 7,042, which gives us a total of 7,043 entries, 21 columns. And among these columns, we have, most of them are objects, except for senior citizen, which is an integer, tenure, which is an integer, and then monthly charges, which is a float. So it gives us an understanding. We know that most of the columns we have are objects. or categorical values, and we will have to work on them based on their type. That's the type. So I would like to check if there are missing values in the data frame, and we use the df is null dot sum. It gives us a sum of the null values in the dataset. So thankfully we do not have any null value in the 7042 rows that we have, which is a good thing, because if we had null values we'll have to clean that all. And I would also like to check if there are duplicates, and you can see the sum of the duplicates. We do not have any duplicate, which is also a good thing, because if there are duplicates we'll have to drop the duplicates. The next thing I'll do is to find kind of a summary of statistics of the numerical columns, which we use the df.describe. It gives us a summary of the numerical columns that we have. You can see the senior citizen, tenure, and monthly charges are the numerical values. Remember, they are the integers, and the monthly values is the float. So this is the summary of statistics. Mean mostly correlates with the 50% IQR, but well, we'll work on it. This is what we have. We have a count of 7043, like I said earlier. The maximum value here is 1 for senior citizen. I think it's between 0 and 1. The maximum value, the range, starts from 0 and ends at 72. Then the monthly charges starts from 18 and ranges up to 118.75. The next thing I think I will do is I've checked the numerical values. Now I need to check the summary of statistics for the categorical values, and it gives me an insight on the data frame I'm supposed to work on. You can see the count. I have a total of 7043 values in each of the columns. There are 2 unique values in the gender, which is correct because we only have 2 gender, male or female. So having more than 2 means there's a problem with the data set. And if we look at it very well, I think even the churn is supposed to be yes or no. That is why we have 2 unique values. And its frequencies, either yes or no. One of okay, the top appearing is the male, which has a frequency of 3555 out of the 7000. And then you can see the others. The top in the dependence is no. The top in the internet service is fiber optic. The top in the churn is no, which has 5174 a frequency of 5174. So in essence, I have a feeling that the no is more than the yes, and it might affect our modeling. We'll have to work on it. I can still check the unique values once again and confirm. Like I said, the gender has only yes or no. The churn, either yes or no. We have 3 unique values here. We have 73 different unique values in tenure, and we have in monthly charges 1585 different unique values. Likewise, the total charges have different unique values. So like I saw earlier before, I saw that the churn has a lot of no's and little yeses. You know what churn means? It means whether a person has stayed or left the company. And we're going to use the PLT. If you remember the PLT actually is a short form of the matplotlib. You can see it here. The short form is PLT. Acceptable is acceptable across the world, and SNS stands for seaborne. So we use the PLT to visualize our data. Plot.figure. This is our figure size, and we use 6x4. I can choose to increase it if I like. Then the SNS, like I said, the seaborne is used to give us a count of churn from the data frame. The data is from the data frame. The title of distribution will be churn distribution, and by the x side we will have churn. Then the count will have the y level, the y if you remember our graph secondary school, x by y, and the plot.show will show us the graph, and I think we can see it here. The no is more than 5,000 and the yes is around 1,800, which we need to work upon because there might be a kind of bias if we are going to work with more no's than yes. This is how our churn distribution is. There is more no than yes. So the first thing we need to do is, if we remember very well, our total charges. Let me show us our data frame once again. df.head. Let's look at the first 10 values. We'll look at the total charges column. It is actually supposed to be in numeric, but I think it came as a text. Where is the total charges? Yes, you can see the total charges is here. It was saved as a text instead of as a numeric, so there we're going to have issues with it because the computer understands numerics much more than it understands categories. So we're going to we call on the particular column df total charges, then the pandas, we now change it to numeric, this particular column, and when we do that we ought to have it's supposed to be changed into a numeric. We can still check on it if we like. df.head, the first 7 values, and let us see whether truly it has been changed to numerics. And yes, look at it, you can see that it is now it's more like a float now, having 2 decimal places across, unlike the first time where it was having, we can see single decimal places and double decimal places. Now the next thing we need to do is to replace any null value within the total charges. If there are null values, we call on the column, and then if there are null values, we fill it with 0 to cover it up. We do not want to have any issues arising from missing values in that particular column, and we need to verify if there are no missing values remaining. We'll check again our data frame is null, sum of all null, and we see that we have no null values, which is a good thing. Now the next thing we'll do is we need to create some new features, and why do we do this? We're trying to change this into a format that the computer can understand, and doing that means we encode it, we change it to a numeric form that it understands very well, and that is why we create new features or new columns. Monthly charges per tenure, where we can see we are using the numpy here to change and bring about a new column where we divide the monthly charges by tenure. We create another column, total charges per tenure, whether there is service or not, and then we use yes or no. Those values that are 0, we equate it. If it's x is equal to no, then that is no, and then or else 1, which 1 is yes, 0 is no, and 1 is yes. So I run it, and when I do, there is a particular data column that is virtually not important for us, which is the customer ID. We are going to use the df.drop to drop that particular column because it has no importance to us. Let me show you the column. Here is the column, the customer ID. It's just an ID. It will not help us in our modeling, so we do not need it, and therefore we are going to drop it. So once I click enter, it ought to have dropped by now. We can confirm and see whether truly it has been dropped. And how do we do that? We can use our df.head yes, you can see earlier we were having the first axis 1 as customer ID. Now axis 1 is gender, which means yes, we have removed the customer ID. Now the next thing we'll do is to encode our categorical variables. Remember I told you the computer does not understand category values, rather it understands numerics, and we need to provide it into a format that it can understand, which can be either form of binary encoding or one-hot encoding and the rest of them. So the categorical variables will select each type. We select each type that is an object, and we will do not the churn will drop the churn for the time being, because we won't you know you'll see what we'll do with the churn later. We now perform one-hot encoding. One-hot encoding is actually good, as it helps us to make sure that the categorical values are changed into zeros or ones or yes or no, and it's going to be in a format that does not show hierarchy. Unlike binary coding and the rest, this one does not show hierarchy. Either this one is bigger than the other one, but rather it all changes into a format, into a way that the computer knows that it should not relate it with any form of hierarchy. And then we encode the variable churn as either yes or no. Like I told you, the churn now will now be either where we see it says yes, it represents as 1, and where it says no, it represents as 0. So I run it too, and when I do, wow, there is okay, name categorical calls is not defined, which means I have not run the cell. Once I've done that, let me run it again. Yes, now it has been run. I don't have any issues. Then we need to scale our numerical values. And why do we scale our numerical values? It is because without scaling there will be an imbalance, and any imbalance within a data set will cause us issues. So we transform our numerical columns and scale them, which will be easier for us to make our analysis. The next thing we are going to do now is to split our data set into training and test data. You remember we imported sklearn at the beginning, so we will separate our data into two. Most of it, 80%, will be for training. Then we use the remaining part for testing, and that is why we have xtrain, xtest, ytrain, and ytest. And we ask the computer to separate a part of it for testing. This random state, the general acceptable, is 42, and we share it into the training and the test data. But before we continue, we need to handle the imbalances. And when we say handling imbalances, we saw that the customers stayed more than left. Those that churned, the answer for no was more than the answer for yes, and it will skew our data. It will not give us a good analysis. Therefore, we need to generate synthetic churn examples so that both classes are equally represented. We don't want any form of bias, and we don't want the model to look at it as it should take more no than yes. And to prevent that, we are going to use this mode. We apply smooth to the analysis. I check first the amount of churn distribution before smooth. I have 4,139 no's, and then that is no, and yes, which is 1, is 1,495. So I apply this mode. I'll apply this mode, and then I'll check it after the application. Okay, now I can check it after. Good. Can you see now that we have a balanced number, 4,139 on both sides, which helps us in our modeling, and it balances the class distribution as if both of them are the same, so that the computer will not be biased towards any. And the last thing I will do is to combine the resample training data for preview. Let us preview what we have. This is what we have now. Let me use so that you can see very well df dot head, the first 10 values. You now see, or let me just say df and you see what we have. You can see now that our gender remains as it was, and we are supposed to have some new columns. Let me just use the df.head and then we'll see what we have. df.head. Good. I want to see the other columns at the end. Good. You can see the new columns that we had. We developed monthly tenure per charges, total charges per tenure, has internet service. 1 stands for yes and 0 stands for no. Does the person have internet service? 0 is no and 1 is yes, which means you'll be able to work on the data like we've promised. And I think as it is, this is now ready for exploratory data analysis, the EDA. Thank you very much for staying with me, and I'll continue to show you more about what I'm doing, about my tasks. And if you have any question, please feel free to ask me. Thank you very much once again.